We are live. Hi everyone, welcome back to Geeks for Geeks practice. Today in this video we'll be discussing the problem of the day for 15th of January. The problem name was merge two binary max heaps, and this type of problem has been asked in a company like Amazon. The level of this problem is easy. The accuracy level for this problem is 67%, and the number of submissions for this problem are 7800 plus, right? So this is an easy level problem, and if someone has basic knowledge of max heaps, min heaps, or you can say binary heaps in general, so he or she would be able to do this question quite easily. So please consider giving me a quick +1 in the chat, and also give a thumbs up to the video. Please like the video if my voice is clearly audible and my video is also visible, right? And then within some time I'll start with the problem for today, right? So in this problem, what you will be given is, you will be given two binary max heaps, right? You'll be given a max heap. I'll be telling you all as well that what is a max heap in general, and you'll be given two binary max heaps, and you have to merge them, merge the given two max heaps into a single max heap, new max heap, right? So this is what the question says. So am I audible, and is my screen clearly visible to everyone? Is it? Okay, please consider giving me a quick +1 in the chat if everyone is clearly able to hear me out, and my screen is also visible. So we'll start right away, and also like the video, and let me know in the comments how many of you have solved this problem today, yesterday, right? So the problem name is merge two binary max heaps. Okay, so you are given two binary max heaps as an array. They are represented in form of an array. Hi Lalit, and hi Snake, hi Anil Shukla, right? So you have to merge the given heaps to form a new max heap, right? This is the question. So let's suppose that you have been given the first heaps as something like this. Let's suppose that you have been given the first heap as something like this. That is, the first heap can be like this, that is 10 5 6 and 2. Let's suppose that the first heap is 10 5 6 and 2. So the first heap that has been given to you is 10 5 6 and 2. So if you will draw this, so this will the representation will look like this: 10, then 5, and then 6, and then here you can say 2, right? Something like this. Let me show you here as well. Like you can see 10 5, then 6 and 2, where 2 is connected to 5. Then you have 12 7 and 9. You also have 12 7 and 9. So you have this thing, right? Let me write it here somewhere. Okay, yeah, so just give me a second. In the meantime, it's openings, right? So another heap that you have is 12 7 and 9. Let me show you what this looks like. So this is 12 7 and 9. So in the end, you have to merge these two and make a new max heap, right? You have to make a new max heap. So you can see that 12 is at the top, then you have 10, then you have 9, then you have 2, then you have 5 7 and 6, like this. Okay, so this is what you have to do in this particular problem. Now the thing is that how will you eventually do this, right? How would you eventually do this? So has anyone got any idea how we can merge these binary heaps, two max binary heaps, to make a single binary heap? Anyone has got any idea? Anyone would like to tell me any particular approach that we can apply for this particular problem? Any approach from your side? Any approach that you would like to recommend? First of all, the first things first, you can notice that you have the first heap, right? You have the first max heap, and then you have the second max heap, right? So what you could do is, to merge this, you can put all these values in an array, since in the end you have to just return a vector or an array, right? So you can put all the values of the first max heap into an array, then you can put all the values of the second max heap into the same array, right? After that, you can simply sort them in decreasing order, right? You can simply sort them in decreasing order, and in the end, how will that help? How would that help? So let's suppose you have something like this, that is, let's say you have 3 2, just give me a second. Okay, let's say you have something like this. Let me draw it. Let's say you have 3, then you have this thing 2, and then 1, right? You have 3 2 and 1, like this. And then let's say you have 7, you have 8 7 and 4, right? Something like this. So 8 7 and 4 would look like this. Okay, so what you could do is, you can put all these values into a normal array, that is you put 3 2 1, then you put 8 7 and 4 like this, and then you simply do what, you simply sort them in decreasing order. You sort them in decreasing order. So what will the new array look like? The new array would look like 8 7, then 4, then 3, then 2, and then 1, like something like this. So in this case, it is also mentioned that it is not mentioned in the problem that you have to print a particular type of max heap. So they, you know that there can be multiple answers if that is a max heap, because there can be multiple max heaps possible for a particular data. So that is why it will not trouble you, right? So with this data that you have sorted in decreasing order, you can see 8, then 7, then I have 4 here. I had 6 also. Let me just check. No, I did not have 6. Okay, right. So this is 8 7, and then I have 4. After this I have, let's say, 3 here. I can have 2 here, and I can have 1 here, right? Like this. So the thing is this much part clear to everyone? Please consider giving a like to the video if the basic part, that is, you can sort in decreasing order, sort the given data, put all of them in a array, in a normal array, and you can sort in decreasing order, and you can simply return your decreased answer, right? Because this is how a max heap would look like. Another way, let's say, could have been, let's say, if this was not the representation that you did, another way to represent it could have been this. Let's say this was something like this, then 2 and 1. So there could be multiple ways to represent it, but still it is a max heap. This is also a max heap, right? This is also a max heap, and this is also a max heap, right? But the thing is that how did you get this yellow max heap? So you got this max heap by sorting all of them in the reverse order, in the decreasing order, right? If you sort it in the decreasing order, then in that case, how does it help? It helps you because if it is sorted in always decreasing order, right, so you know for sure that it will be a max heap, right? That is the best possible scenario that you can have, that if it is sorted in the decreasing order, then it will always, the resultant array would always represent a max heap, like this. You can see been given to us. So it was 10 5 6 and 2. Let me write it. This was nothing but 10 5, then we had 6 and 2, then we had 12, we also had 7 and 9, right? 12 7 and 9. So we had 12, then we had 7, and we had 9. So let us quickly put this in one array and sort them, write them in sorted order. So I have written 12, I have written 10, I have written 9, I have also written 7, I have written 6, I have written 5 and 2, like this. Okay, so this, you can see this, if you just return the final answer as this, something like this, in that case, that is the final answer. Why? Because this is the complete array, this is the complete merge array in sorted form. I can see a lot of people are watching, so please consider giving a like to the video, because we'll be discussing 2 more approaches after this approach is done, right? So what I can see is 12, then with 12 I can have this representation, that is 10 and 9, then with 10 I can have children 7 and 6, then with 9 I have children 5 and 2, something like this. So this is also one of the possible answers, you can see, because this is nothing but the sorted representation, sorted max heap that I have made. So you can see this is also a max heap, right? And since you can return any max heap that is possible, you just have to return a new max heap that is a new heap, that is a max heap, which is a merging, which is obtained by the merging of the first and the second max heap, right? So that is why, if you see, so this is also max heap. So this is one of the ways that you can do it. So for doing this, what you will be doing is you can simply say that you have n plus m elements, right? N elements from the first heap, right? Can I say that I have n elements from the first heap, and I can say that I have m elements from the second heap, right? So total elements, what? Total elements is equal to what? Total elements is nothing but n plus m, right? Total elements is n plus m. If I am sorting them in decreasing order, so if I had n elements, if I had, let's say, n elements, so the time complexity would have been n log n, right? Since I am sorting in decreasing order, since I have n plus m elements, so the time complexity would be what? N plus m log of n plus m, something like this, right? Is this much part clear to everybody? If this part is clear, please consider giving a like to the video, and please give me a +1 in the chat, right? So the time complexity would be, if I am sorting directly in the overall array, if, the complete array, total all the elements, if I am sorting them in decreasing order, the time complexity will be order of n plus m log of n plus m, right? Something like this. Now for this particular approach, the space complexity would be what? Since I am storing all of them, all the n plus m elements, right, in an array, so that is why the space complexity would be nothing but n plus m, right? The space complexity would be order of n plus m, because total n plus m elements are being stored by me, right? So this much part is clear, right? The first approach was sorting. Now let's talk about the second approach. Second approach, is there, first of all tell me, is there any particular data structure, is there any STL which is helps us to implement max heap? Is there any STL which helps us to implement max heap? Is there any particular data structure that will help us to implement max heap? Is there any particular STL function or thing like that that will help us to implement a max heap? What is that? Does anyone know? Just quickly comment down below. Also like the video if someone new has joined, right? Is there any particular STL? Is there any particular thing in the STL that will help us to implement max heap? Yes, there is. There is one thing, and that is known as priority queue. That is known as priority queue, right? Yeah, Chirag is correct. Priority queue. Priority queue. With priority queue, I can implement a max heap as well as a min heap, right? By default in C++, you have a max heap that is implemented in it, right? Yeah, Dipanshu, you are also correct, right? So I can say this is priority queue in STL. I can declare it like this, right? Like something like this, priority queue. Then I can have int. It can also be declared in Java as well. The max heap priority queue, right? The max heap that can be declared. This will look something like this. Can I say that this is nothing but the max heap? Where in this what happens? In this, if I do pq.top, so at the top most element, the top element, or the first element, the topmost element of a priority queue is what? The topmost element is the maximum element, right? Maximum element. So that is why this represents a max heap, and it is implemented internally. So what I could do is, can I say that I have first array A, then I have the array B, right? I have these two arrays. What I could do is, I can simply say that for I starts from 0, I have already declared a priority queue, right? I is less than n I plus plus. What I could do is, I could do priority queue dot push A of I. First of all, I push the elements of the first array, right? After that, what I do, I push the elements of the second array into the priority queue, and the heapify process will take place. In the priority queue, or the, you can say, the max heap that we have made, the heapify process will take place. So the maximum element will always be coming at the top, right? The maximum element would always come at the top, right? So the heapify process would take place. So that is why I starts from 0, I is lesser than n, right? And I is lesser than m, that is the size of the second array, and I plus plus, and I simply do pq dot push B of I, right? So every time I'm pushing an element, so the heapify process will take place, right? So in this way, once this is done, so what I could do is, I can show you the code probably for this part, right? What I will be doing is, like, I can make a vector that will be named as merge heaps. That is the final vector that I'll be returning. I can also name it as result, that depends on us, right? So the size would be n plus m. So I declare a priority queue in C++, that is the max heap. You can declare that in Java as well, or any other language of your choice. I first of all push the elements of the first array, that is I first of all push the first max heaps elements, then I push the second max heaps element. Then what I do, I simply pop out the elements one by one. And I start filling them in an array. Since I have made a max heap, so what will happen in this case? Let's say I have elements as, let's say, 10, 5 and 6, something like that. Okay, another one that, let's say, I have 8, 7, 2 and 1, something like this, right? So what will happen in the priority queue? What will happen? All this data will get inserted, right? All this data would get inserted. So let's insert the datas, right? 5, 6, 10, then 7, 2, 1, 8. All these datas will get inserted, right? After that, what will happen? The heapify process will take place, right? Every time when insert an element, the heapify process will take place. Now notice that after all the elements are inserted, so all the elements are inserted, like 10, 5, 6, then you have 8, 7, 2 and 1, right? All the elements of the array A and the array B I have inserted in my priority queue, or I can say max heap, right? After this, this is nothing but the priority queue implementation inside, right? So heapify process will take place. So what will happen with this heapify process, always the top element, that is pq dot top, you can notice pq dot top, always the top element of the priority queue will be the maximum element, and that is the property of the max heap, right? So that is why what will be the top element? So the top element will be 10. So I have declared an array of size n plus 1. So what I will be doing is, first of all, I insert this element 10, then I pop this out, right? Okay, so I have n plus m minus 1 elements now. So for one element, for the first element, how much time I took for heapify process? I took order of log. If there are n elements, then I take log of n time in the priority queue or the max heap to do the heapify process. That is making the maximum element or the top element or the maximum element at the top of the priority queue, right, of the max heap, right? So that is why if I have n plus m elements, so for very first element, the largest element, that process will take n plus m times, right? After that, if I am choosing for the second largest element, what is the second largest element in this? So can I say that 8 will now become at the top? 8 will be at the top of the priority queue since 8 is the largest element. So what I pop this out as well. So this will also, the heapify process to make this 8 the topmost element would also take, yeah, right, it will be in descending order only, but I am telling you about the heapify concept, like how it is actually implemented, right? So this is nothing but 8, right? So I'll have 8 as well. So for this element as well, can I say that it will be nothing but the heapify process will take log of n plus m minus 1? And can I say that log of n plus m minus 1, if n and m are very large, then it will be very similar to log of n plus m, right? So for one element, for heapify process of one element, I am taking log of n plus m time. Okay, notice that. Then I have popped out 8 as well. So which element will be at the top? Can I say that the element at the top will be 7? Yes, the element at the top would be 7. So I'll write 7 as well, right? Then I'll pop it out. Then the heapify process would take place again. So it will again take the heapify process for the particular element would take n plus m time, right? N plus m time. After that, so 6 will be at the top. So I pop out 6 and I insert it into the array, right? After that, the 5 will be at the top. So I put 5. After that, in the priority queue, 2 will be at the top. So I put 2 in the array. Then only one element is left, and that is 1. So heapify process will take place and will be at the top, right? So this is how my final array merged array would look like, right? This is how my final merged array would look like. Okay, so this is how it's happening, and I have already told you that the concept here is heapify. The moment I remove the topmost element, that is 10. So 8. The moment I remove 10, so 8 becomes the larger. 8 becomes the top. 8 becomes the top element, or 8 becomes the top of the heap, right? And that is what heapify process does. The moment I remove 8, so the next greatest element becomes at the top, right? So the heapify process for one element, it takes log of n time. If there are n elements in the priority queue, if there are n elements in the max heap, so the heapify process takes log n time for heapify for one element, right? If I remove one element, then to heapify again, if there are, so here I have n plus m elements. So if I remove one element, then after that the heapify process would take log of n plus m time, and I am similarly removing all the n plus m elements. So for one element the heapify process is taking log of n plus m time, so for all the m elements it will take nothing but log of n plus m and log of n plus m time, right? Okay, this much part must be clear to everybody. I hope that it is clear to everybody, right? So this will be nothing but for heapify process, after removing one element, will take log of n plus m time in the priority queue or the max heap, right? So for removing all the n plus m elements and inserting that into a final array, it will take, for the all plus n plus m elements, if for one element it is taking log of n plus m, so for the n plus m all elements, so it will take n plus m log of n plus m, right? So is this part clear to everyone? If this part is also clear to everyone, please consider giving a +1 to the video, right? So this was the second approach. Now there is a third approach as well. Can someone let me know, is there any other approach for this? Can we do this in linear time? Can we do this in linear time? All of you, please consider giving me a quick +1 in the chat, and please like the video if you haven't done that. Okay, please like the video and please give me a +1 in the chat if these two approaches are clear, right? So now let's discuss the third approach that we'll have. What is the third approach that we can have? Can we do this in linear time? Yes, we can do that. What we could do is, let's say you have this max heap, right? You have this max heap 10, 5, 6 and 2. Let's take this example only. So you have 10, 5, then you have 6 and 2. Okay. This is the max heap number 1, that is A, is equal to 10, 5, 6 and 2, and the second one is 12, 7 and 9, right? The max heap B is nothing but 12, 7 and 9, like this. Okay, So the second max heap is 12, 7 and 9, right? So what I could do with this is I could have 2 pointers, right? I could have made 2 pointers. I have made, let's say I made one pointer point to here and the second pointer j point to here, right? So if I'm making a max heap, so which element, just heapify once using internal loads. Okay, yeah, right. That is also, the Panchu is also okay. Your solution is will also work, I think, right? So now I put these two elements. So which is greater element? Which element is greater? Can I say I have put all the elements and I will check that while I is lesser than n and j is lesser than m. Okay, I am checking this. So which element is greater? Which element is greater? I have a array, final array, that is of size n plus m, and I let's say that array is ARR or something like that, right? So how will I do this? How will I do this? How will I do this? Can I say, will I insert 10 first of all in the array or will I insert 12? So if I say if my b of j is lesser than a of I, in that case what will I do? I'll say that in the final array ARR of k, can I say that ARR of k is equal to k is currently pointing to 0, okay? So that is the first index. So can I say that the answer would be nothing but I'll first of all add what? I'll first of all add this element, right? 12 or what? If this element is greater, right? Sorry, I've made a mistake. If b of I is greater than a of I, if b of j is greater, if the jth element of the second array is greater than the first, if the ith element of the first array, in that case can I say that the kth element would be b of j? Yes, I can say that. So that is why what would be the what will be stored? Let me just redraw it again so that we can have some space. Okay, just give me a second. Okay, right. So now what will happen in this case is, let's draw it. Okay, right. So now k is currently k is 0, right? So this is the first index. So what will I put? I'll put 12. Yeah, comparison. This is nothing but comparison, right? Because I want to make a max heap. So I'll say okay, 12 will be put. Then after that, what will I say? I'll say that now my j should move to this point. So I'll say j plus plus, right? I'll say j plus plus, and if it happens, then I have I as this element. I have I at the a of I. What do I have? I have 10. At the b of j, what do I have? Now my k changes to 1. I have also done a k plus plus here. Okay, I'll do a k plus plus as well. So the k points to this point, right? What will I insert? What will I insert? Will I insert 10 or 7? So a of I is 10. A of I is coming out to be 10 and b of j is coming out to be 7. So what will I insert? I will insert 10, right? I will insert 10. So let's insert 10. So what will I do in the else part? If this part is not inserted, so that means I'll insert the second part. So array of k is equal to nothing but a of I, right? After that, what will I do? I'll do a k plus plus, indicating that the I need to move to the next index, right? So k moves from here to here, and after that, what will I do? I'll do I plus plus, so that I points now, instead of pointing to 10, it will point to the next element of the max heap, right? Instead of pointing to this 10, it will point to the next element. And what's the next element that it should point to? It should point to 5. Okay, so now it will point to 5. So it points to this particular index, right? Now I have j as 7, b of j is 7, and a of I is what? A of I is nothing but a of I is nothing but what? A of I is nothing but 5. So which element is greater? Which element is greater? Can I say that b of j is greater? Yes. So I'll insert b of j. So 7. Then my j increases again. So j is pointing to 9 now. Okay, j will point to 9. And now I will remain the same. So which element is greater? Which element is greater? Is 9 greater or 5 greater? So 9 is greater. So I'll put 9. I'll insert 9. Once I've inserted, merge the second heap is exhausted. I have put all the elements. So after that, I'll put 5, 6 and 2. Okay, I'll put 5, 6 and 2. That is all the elements that are remaining in the first heap, right? So let me remember this 12, 10, 7, 9. Let me write it here somewhere. So this is nothing but 12, 10, 7, 9, 5, 6 and 2. Let's see whether this is a max heap or not. Let's see whether this is a max heap or not. Okay, this is nothing but 10, 12, 10, 7, 9, 5, 6 and 2. Okay, let's see whether this is a max heap or not. Okay, let's see. So what is the first element? I can say that the first element is 12 in this particular array that we have got as the merged one, right? What do I get? 10. The first element is 12 of this particular max heap. Then 10 is the child. left child, 7 is the right child. After that 9 is the left child of 10. After that 5 is the left child of right child of 10. Then 6 is the left child of 7, and this is 2. So is this a max heap? Yes, that this is a max heap. This is a max heap, right? This is a max heap. So you can see that it is not necessary that elements need to be sorted. It's not necessary, as I said, that the best possible answer could be that all the elements of the max heap are sorted. Also, say if someone new has joined, I can see a lot of people are watching us live, so please consider giving a like to the video if this much part is clear. If you have some doubts, so please write that. If this much part is clear, so please consider giving a quick +1 in the chat, so that I know that this part is clear, like how we are merging. So you can see actually all the elements are not sorted, right? You can see 9 is appearing after 7, like 7 is occurring before 9. You can see 5 is occurring before 6. So you can see 7, that's 9, your 5 is occurring before 6, right? Things like that. So that is why this is not in the sorted order, but that does not matter, because still this is a max heap, right? Still this is a max heap. In these also, the max element will be at the top. Always the max element will be at the top. Like you can see this. So this is what this is a heap, and this will represent a max heap, because the maximum element will always be at the top. You can notice from this, like first of all 12, then 10, then 7, then 9, like this. All the elements that are greater will be at the top, right? So that is why this approach will also work. So for doing this approach, what did I do? I made a pointer on the ith array, ith element of the array, and on the jth element of the second array, right? Array A, array B. So I merged them simply, right? I merged them. So that means I took a space complexity of again order of n plus m, because I had to insert them into an array, and I linearly iterated through each element exactly once until I reached the end of the array, right? I exhausted all the indexes of the array. So can I say that the time complexity is what? I can say that the time complexity of this particular approach is nothing but order of n plus m only, because I am doing a linear traversal. I am traversing through each element of both the arrays exactly once. So that is why for this particular array I am taking order of n time. For this particular array, for traversing all the indexes, I am taking order of m time, and that's why this is nothing but order of n plus order of m. So it can be ultimately written as order of n plus m. That is a linear approach, right? Sir, second method is repeated. I am not understand. Okay, I'll repeat that. Anil Shukla, I'll repeat that. But first let me know, is this approach clear? If this approach is clear, please like the video. Please like the video if this approach is clear to everybody. Is this approach clear to everyone? Is this approach clear to everybody? I'll repeat the priority queue method as well again. But first let me know if this approach is clear or not. Let me show you the code part for this particular approach. So the code part that I have written for this one, you basically declare a vector, right? You basically declare a vector of size n plus m, or an array of size n plus m, right? You mark your I to 0, j to 0, in that is you are pointing to the first element of the first max heap, the second max heap, and then the max heap that you will be making. So k is equal to 0. If my I is lesser than n, right? If my I is lesser than, and I is pointing to the first max heap, the array that is representing the first max heap, j is pointing to the indexes of the second max heap, right? Then if my a of I is greater or equal to b of j, so if my ith element of the first array is greater than the jth element of the second array, in that case what will I do? In my result I'll put first of all a of I, because a of I is greater, right? A of I is greater than b of j, so I'll be putting that. After that I'll do an I plus plus. I'll simply do an I plus plus, right? Else what I'll do? Else that means that I need to put in, I can say that b of j is greater than a of I. So that is why I'll put the element at the jth index of the second max heap, right? So that is why I'll say result of k is equal to b of j. Then I'll do an j plus plus, and after I can say I'll do a k plus plus. You can do a k plus plus here as well. Like after putting each element, you can do a k plus plus like this. That this will also work, right? So you are basically incrementing the index so that you can point to the next element in the new array that you are making, right? In the new max heap that you are making. After that, what do I do? If, as I said, let's suppose in this case, if the second heap got exhausted, right? The second heap got exhausted, the second max heap got exhausted. So in the end, whatever elements are remaining in the first max heap, I'll be putting them inside my resultant max heap that I'm making, right? After that, it might also happen that the first array might have got exhausted. It might happen that all the elements of the some elements of the first array were greater than the all the remaining elements of the second array. In that case, what will that mean? So it might happen that the first array elements might have got exhausted. So that is why only the elements remaining would be in the second array. So that is why I'll insert all the remaining elements of the second array, that is the second max heap, into my array, and then I will simply return the resultant vector, right? Is this much part clear to everyone? If this much part is clear, please consider giving a quick +1 in the chat, and please give a thumbs up to the video if you have understood this, right? If you have understood this much part, please consider giving a +1 in the chat. Is it clear to everybody? Is it clear? Please give me a +1 in the chat, and please like the video if this much part is clear, right? So we discussed 3 approaches, right? We discussed 3 approaches for this particular problem. The approach number 1 was using sorting, right? Sorting all elements in decreasing order, right? In decreasing order. And for that, I took a time complexity of order of n plus m log of n plus m, right? And the space complexity was nothing but order of n plus m, right? Because I made a vector that was returning. Then the second approach was using the priority queue, that is implementing that is priority queue, that is implementing max heap using the C++ STL or Java libraries, C++ STL or Java library, right? Java library functions that are available, or any other language, right? So in that way, what I could do, see the time complexity with that approach. For one element, for heapify process, I was taking order of n plus m time by removing one element. So after removing all the n plus m elements, so the time complexity would have been n plus m log of n plus m, right? Same. And the space complexity would have been order of n plus m, because I was storing n plus m elements in my priority queue. After that, what was the third approach that we discussed? The third approach that we discussed, this is approach number 1. This is approach number 2. And this is approach number 3. Right, approach number 3, what we did in the approach number 3, this was a linear approach. In that, what we did, in that we just there's a similar question to this, that is merge 2 sorted arrays. So you can also check out that problem, but the concept is a little bit here different. The array does not need to be completely sorted here, because this is a max heap, right? So the max heap can will in only the topmost element is the current topmost element should be the highest, right? So that is why this took a time complexity of order of n plus m, right? Because we linearly iterated to each element of the array is exactly 1, so that is why order of n for the first and order of m for the second. So that was order of n plus m, and the space complexity for this was nothing but order of n plus m, right? Because we inserted all the elements into a vector, right? That's why, or a list in Java, right? Is this much part clear to everyone? So all those who are watching new, who have just joined now, they can watch they can just move back and they can watch. I've explained all the 3 approaches in detail. And apart from this, just like the video if you haven't done that. Please like the video and comment down a +1 if everything is clear. Everything is clear, then please comment down a quick +1 in the chat. Everything is clear, then please comment down a quick +1 in the chat. I want a quick +1 from everyone in the chat. Okay. Now the thing is that, thanks Anit Shukla, all others I expect a quick +1 so that I know that everything is clear, right? So what I'm saying is, what was the second approach that I said? Just repeating the second approach. So approach number 2 said that I was using a priority queue, right? I was using a priority queue, that is a max heap that is already present there in the internal implementation, right? So let's suppose I have this max heap that is 3, 2 and 1. Another max heap is, let's say, 7, 4 and let's say 5, something like this, right? So in this case, what I would do, I would insert all the elements. So 3, 2, 1 I'll insert, then I'll insert 7, 4 and 5. So all the elements are inserted. So for one element I was saying that this is a heap, right? This was the heap. So I was saying that for one element, the heapify process means what? Heapify process is nothing but maximum, making the maximum element, the topmost root of the tree, root of the binary tree, the maximum element, right? The root of the binary tree should represent the maximum element, right? So that is why maximum element at the top. The heapify process is nothing but making the maximum element, or the root, making the root element the highest element, right? So bringing the maximum element at the top of the binary heap that you have. So heapify process for one element takes order of the number of elements that are log of n time if there are n elements. If there are n elements, so the heapify process takes log of n time. So since there are n plus m elements, so the heapify process for one particular element would take n plus m time. So what is the topmost element here? Can I say that the topmost element is nothing but 7? So I will pop out 7, right? Once I pop out 7, so what will happen? Now this will heapify again. So you can see that there are n plus m minus 1 elements. So if n and m are large, so that is why minus 1 won't matter much. So that is why this will again, to bring 5 at the top of this particular priority queue or max heap that is already implemented in your library functions. So for this it will take again log of n plus m time, right? So then I pop out 5 as well. Once I pop out 5, so again it will take order of log of n plus m time for the making it heapify again and bringing the next topmost element. So the topmost element now will be 4. So I'll print 4. I'll now print 4 and I'll pop it out. Then the heapify process will take place again and 3 will be the topmost element. So 3 will be there, I'll pop 3 out. Then after that 2 will be the topmost element after the heapify process. After that 1 will be the topmost element of the heapify process. Then my priority code would be empty, right? So for one element, the heapify process is taking log of n plus m time. So after removing all the n plus m elements, it will take n plus m log of n plus m time, right? This is what I was trying to explain. And this priority queue is already implemented. This max heap concept is priority queue that is already implemented in C++, Java and other languages, right? So is this approach also clear to everybody? If this approach is also clear, like this was also a simple approach, so please like the video if you haven't done that, okay? Is this approach clear to everyone? I hope that this is clear to everyone, right? So this was the problem that we discussed. Now let me show you some more things. So we have this problem of the day concept, and tomorrow we'll be having this step by today's problem of the day, that is the problem of the day for 16th of January is steps by night. So you can consider to solve this problem as well. There are 9 hours still remaining. You will be getting Geeks for Geeks coins for this, 1 coin for each day that you solve, okay? So make sure to solve this problem, and this problem merge 2 binary heaps. I'll be telling you that if you will keep on consistently doing problem of the day on Geeks for Geeks, then it would help you to increase your knowledge of data structures, algorithms. Also you'll be making yourself tackle a lot of random problems, right? Because if you do it topic wise, then it becomes easy, but if you do random problems random topics, then it will be more helpful, right? Another thing that I want to tell you is, if you like my explanation, if you like my way of teaching, so this is the channel, that is an initiative that this channel is powered by Geeks for Geeks. So the channel name is Codera. We consistently put lead code daily challenges on this particular channel. We also have put a lot of videos on Codeforces editorials, SQL of HackerRank, and a lot of other things. Like I am also doing you can see I am doing a mastering Codeforces binary series. You can check out the channel and make sure to the channel will be present in the featured section, or you can just search for Codera and you will this channel would be available to you. So you can just go through the various playlists that are available of AdCoder mastering Codeforces series of sorting, searching, game theory and binary search that I have done. Apart from this, a lot of Codeforces AdCoder contest, lead code weekly challenges, bi-weekly challenges as well. So you can check the channel out and make sure to subscribe the channel if you like our content. And this was it from my side. Make sure to keep coding, and once you have solved the problem of the day for today, come back to this video and comment down that you solved the steps by night today, okay? Comment down and what was your approach. Also I have also check out it, and from 4 p.m. today I'll be doing, you can see in the live streams, current live streams, I'll be doing the max distance to the closest point. I'll be doing this particular live from 4 within 20 minutes, right, from now. So max distance to the closest sponsor, and the problem has been asked in a company like Google. This is lead code daily challenge for today, that is 16th of January. So I'll be doing this, so you can consider to subscribe to the channel and make sure to come there. So I'll be solving it there. Thanks a lot everyone for watching, and I'll see you soon in the next video. Till then, keep coding.